Once again, this is www.ez3dbiz.com. Update right here on basically some new discoveries right here on the 0-point energy. Quite simply, what I have here is a piece of copper pipe, and then as you can see, it's hollow. There's nothing inside here; it's completely hollow. And then around here, I have Epsom salts, and then I also have a coating of Elmer's glue. Elmer's glue you can buy pretty much anywhere. And then I used a mortar and paste to basically crush up the Epsom salts, make them to a fine powder, and then basically just coat the copper pipe. Basically, we have a piece of magnesium right here, and when these are dry, these are still wet by the way, when they're dry they're going to be coated with a layer of magnesium ribbon. So basically we'll get a magnesium ribbon and we'll wrap it around here to give it a full contact. Right now these are still drying, so I'm just giving a quick demonstration. Quite simply, I have two of these right here. I put them in series. I don't know if you guys can see that, but I've wired these guys up in series. And then underneath this pipe right here, I have another piece of magnesium ribbon, as you can see right here, to basically conduct the energy. Right now we are on 0 volts. I'll bring the multimeter here a little bit closer for you guys. There's no voltage coming out right here. So what we're going to do now is basically start these guys up and show you the voltage coming out. I'm putting these guys in series. By the way, the same with this one right here. It's a fully clear copper pipe. There's nothing inside. So basically the air is part of the electrode. So what we're going to do now is we're going to connect these up, and I'll show you how much power we're putting out. So this little piece of magnesium right here, same as underneath what's under this one. We'll go ahead and put it underneath and see what we get. Right now we're drawing 3.32 volts. I don't know if you guys can see that there, but that's an easy 3.35 volts. And we're on the 20 meter scale. As you can see closely right there, we're at the 20 volts, 20 voltage scale. Now with this incredible amount of energy right here, it's more than enough to simply light up an LED. So I have an LED right here. I've already connected it up. Put it on here. And you guys can see that, but the LED lights up very clearly, very brightly. This is just a cheap LED I bought on the internet. But I'll do it again, light it up. See the LEDs, pretty much easy to light now because we're putting out about 3 volts. Or more than 3 volts. But the load right here, once I put the LED load on, I'll show you what we're getting. Light up the LED. It's about 1.73, 1.74 volts with the LED lit. So we're drawing about 1.73, 1.74 volts. That's with the LED lit. And there's no problems lighting that LED with simple Elmer's glue, magnesium sulfate, and copper. And once again, everything here is pretty much set up. There's no trickery involved right here. This is basically the setup. All wire leads are solid. No other hidden stuff right here. So what we're going to do is once these are dried out, I'll take this off right here. Once this copper pipe is dried with the magnesium sulfate and the Elmer's glue around it, what we're going to do is we're going to apply sodium silicate. Because this stuff right here, I got 40% sodium silicate. And what we're going to do with that is the sodium silicate will actually be a protector around here, and will protect the stuff from corrosion or from the air and the elements. But as soon as these dry out, we'll put the magnesium ribbon on here, wrap it around, then we'll apply the sodium silicate. And then what we're going to do is once that's completed, we're going to make these into a layer type of capacitor arrangement. So what will happen is we'll have a copper pipe. Let me move this out of the way here. Big copper pipe here. And then what we're going to do, take this out here. We're going to put this piece of copper pipe into here, like this. So you see we've got a second layer right there. Then what we're going to do is we're going to put this third piece in here like this. So we'll have a total of 3 layers. And then I imagine I'm probably going to get around somewhere between 3 and 4 volts out of this. One very interesting discovery is that the size doesn't matter. This size yields the same amount of volts as this size. Obviously, the more coverage that you can get, the better conductivity you're going to get. It's a little bit more stable in conductivity. But I'll see if I can demonstrate that here really quick. This pipe right here. A little easy, a little hard doing this with one hand, but give me a moment here. We'll get this taken care of. Alright, here we go. Now, this piece right here, this is the big pipe, by the way. This is the big piece of copper pipe. Okay, we've got everything ready to go now. Sorry about that. Alright, big piece. Currently right now we're drawing 0 volts, big copper pipe. Put the magnesium on here. We got 1.6 volts, 1.68, 1.67. Alright, now let's use a small pipe. This is the smaller piece. A little bit stronger actually, 1.76. So if you've been reading the literature, you'll see that the smaller it gets, you can actually make these into a nanotechnology size circuits, or not circuits, but small independent nanotechnology size, and they yield tremendous amounts of energy. Small amounts of energy, but actually tremendous amounts. So in the future, we're going to basically be making them probably a little bit smaller than this, and then putting them in series, and hopefully we'll also be able to be putting them in not only series, but putting them into layers like this. So theoretically, you could have a very, very small device layered like this with a tremendous amount of energy, So there's a lot of potential right here. And my next videos will show basically the magnesium ribbon, which will be wrapped around here in a coil. And then after the sodium silicate will be applied to protect it. But it's very important to make sure this is dry first, then apply the magnesium ribbon so the corrosion doesn't occur. I'd like to give credit to IB Pointless 2 for the Elmer's glue technique. That was a pretty good way to help simplify things. Anyway, thanks for watching, and this is easy3dbiz.com coming to you live from beautiful Southern California. Wish you all a wonderful day. Bye.